In this video, we're going to look at experimental probability and how to find it of an event. So in the previous examples, each outcome had an equal chance of being selected. For instance, flipping a coin or rolling a single die. Uh, each outcome has an equal chance, and this is referred to as classical probability or theoretical probability. However, we do have two other types of probabilities, experimental probability and subjective probability. So first up, experimental probability is the probability based on events that have actually occurred. And in our next example, we're going to actually simulate using a computer flipping a coin 10 times to calculate what the probability of that coin flip coming up, I think tails is. But experimental probability is based on events that have actually occurred, where not everyone has necessarily an equal chance every time you perform an event. Also to that, subjective probability is probability that is based on opinion. And unfortunately, with the sheer volume of information out there and online and things like that, it oftentimes becomes difficult to determine what probabilities are theoretical or experimental versus subjective. So sometimes you have so-called experts that give a probability that is based on their opinion, and unfortunately, it tends to go unquestioned. So, be very mindful of subjective probability when you hear information and you hear results, because it unfortunately happens and gets passed off as experimental or more likely experimental probability than you might be comfortable with. So example 2, flip a coin 10 times and state the experimental probability of landing on tails. So in this video, I can't really flip a coin on screen and see what happens. I mean, there might be some site that allows you to do that. So instead, what I'm going to do is simulate flipping a coin 10 times. So I have a Jupyter notebook here. And first thing we're going to do is going to import random as RD, so that way I can actually get random values. All right. So here are my possibilities for flipping a coin. I have H for heads and T for tails. And I'm interested in the number of tails, so I'm going to start that at 0. And it said to flip the coin 10 times. So we can always adjust this number of flips here. But for this one, we're going to flip the coin 10 times using the computer. So for underscore and range, number of flips, so this is going to run this experiment and essentially flip the coin 10 times. We're going to take a random value from this list of possibilities. So that's essentially the computer's way of flipping the coin. And if the result is tails, then so it's going to randomly pick one of these two values. If the result comes up tails, then we're going to add 1 to the number of tails that we had. So if we go ahead and run this, we see that the probability of flipping tails is 0.4. So that means that out of the 10 times we flipped this coin, it came up tails 4 times out of 10. Now, you might flip a coin and it comes up a different number of times out of 10, but the idea is that experimental probability is based on what actually happens. Even though we looked at in the last example, flipping heads and flipping tails, each had a probability of a half. That's classical or theoretical probability, where each of these has an equal chance, not based on what actually does happen. So with experimental probability, you actually have to perform the experiment, hence why they call it experimental. Now, related to experimental probability and theoretical or classical probability, we have what's known as the law of large numbers. And this law is actually very important if you're using computers to simulate events such as flipping a coin or rolling a die or anything like that. So essentially what it says is that as the number of events increases, so we had 10 flips of the coin in the last one, but if we increase that, as we increase it, the experimental probability of the event is going to approach the classical or theoretical probability. So going back to our flipping a coin, we only flipped it 10 times. And we saw that the probability of flipping tails is 0.4. Now, theoretically, the probability of flipping tails should be a half. And as we increase the number of flips, so let's make this 1,000,000 flips. So now it's going to flip the coin a million times and calculate the experimental probability of flipping tails. And what should happen is this result should get closer to the theoretical result of 0.5. So let's see. Got a million flips. So yeah, we have the now if we flip this coin a million times, the probability of flipping tails is 0.50057 in this case. So much closer to the result of a half than if we only flipped it 10 times. And as we increase the number of flips, this probability, this experimental probability, is only going to get closer and closer and closer to the theoretical probability of a half. So very important for computer simulation for statistics is this law of large numbers. All right, so we're going to end this video with some rules of probability. We'll see some more rules as we progress in this unit. But for Probability Club, we have a couple rules, and you are allowed to talk about Probability Club. Our first rule of Probability Club is each probability must be a value between 0 and 1 inclusive. So in other words, if it's a decimal, it's got to be between 0 and 1. If it's a percentage, it has to be between 0% and 100%. And if it's a fraction, it must have a numerator with between 0 and whatever the denominator is. So if the denominator's like 10, the numerator could be 10. 10 out of 10 is 1. So we can never have a probability higher than 1 because that's having more available than what we have to choose from. So a probability of 0 is called an impossible event. For instance, if we roll a standard 6-sided die with 1 through 6, what's the probability of obtaining a 7? There are no 7, so it's 0 out of 6, which is 0. It's called an impossible event. A probability of 1, on the other hand, is called a certain event. So if it's guaranteed to happen, it's a 100% chance of happening. A probability of 1 is a certain event. In other words, the numerator and denominator would equal each other. And then our second rule of Probability Club that we're going to talk about in this video at least is that if we add up all the possible probabilities of a sample space, the sum of all possible probabilities of a sample space must equal 1. So for instance, taking the coin flip, if we take all the possible probabilities of flipping a heads or flipping tails, then we take a half for heads probability, a half for tails probability, a half plus a half gives us 1. So if we add up all those possible probabilities of a sample space, it must equal 1. And this is something that we're going to see also in future videos, especially when we get into normal distributions and probabilities. So, all right, that about does it for this video. Thanks for watching. I'll see you next time.